NEC 300.3 addresses the concurrent occupancy of conductors with different systems. It states that conductors of different systems, including power, lighting, alarm, and communication circuits, shall not occupy the same equipment, enclosures, or be installed in the same raceway or cable unless specifically approved for the purpose. In the scenario presented, looping the travelers down to the four-way switches in a basement using two-wire NM cable and then returning to the same box where the three-way switch is located would indeed violate NEC 300.3. The reason for this violation lies in the fact that the travelers are conductors of a lighting circuit, while the hot and neutral conductors constitute a power circuit. According to NEC 300.3, these different systems cannot share the same cable unless specifically approved for that purpose, and in this case, no such approval exists. The inspector is correct in requiring the use of three-wire cable in all the boxes. This ensures that the travelers and the power circuit conductors are properly separated, maintaining electrical safety and code compliance. To elaborate further, consider the fundamental principles behind NEC 300.3. The primary concern is to prevent the mixing of different electrical systems within the same enclosure or raceway unless specifically permitted. This separation is crucial for several reasons, including safety, preventing interference, and ensuring proper system operation. Firstly, safety is paramount. Mixing different electrical systems can create potential hazards such as short circuits, current faults, and electrical fires. For example, if a low-voltage communication circuit comes into contact with a high-voltage power circuit within the same cable, it could lead to a dangerous situation. Secondly, interference can occur. Different electrical systems can generate electromagnetic interference, which can disrupt the operation of other systems. For instance, the electromagnetic field produced by a power circuit can interfere with the signals in a sensitive communication circuit if they are run together in the same cable. Thirdly, proper system operation can be compromised. Each electrical system is designed to operate within specific voltage and current parameters. Mixing systems can lead to imbalances and malfunctions affecting the performance of the individual circuits. Therefore, NEC 300.3 is a fundamental requirement designed to maintain the integrity and safety of electrical installations. In the context of the three-way and four-way switch conversion, using two-wire NM cable to loop the travelers would violate this principle by combining the lighting circuit travelers with the power circuit conductors in the same cable. The correct approach, as the inspector advised, is to use three-wire cable throughout the entire switch circuit. This ensures that the travelers and the power conductors are properly insulated and separated within the cable, preventing any potential hazards or interference. Now, let's discuss the practical implications of using three-wire cable in this scenario. When installing three-wire cable, it's essential to follow proper wiring techniques and ensure that all connections are made correctly. The three-wire cable typically consists of a black wire hot, a white wire neutral, and a red wire traveler. In the three-way switch boxes, the hot wire from the power source is connected to the common terminal of one three-way switch, while the two traveler wires are connected to the other two terminals. Traveler wires then run to the other three-way switch box, where they are connected to the corresponding traveler terminals. The common terminal of the second three-way switch is connected to the fixture. In the four-way switch boxes, the two traveler wires from one three-way switch are connected to the two terminals on one side of the four-way switch, while the two traveler wires going to the other three-way switch are connected to the two terminals on the other side of the four-way switch. This configuration allows the circuit to be controlled from multiple locations. When running the three-wire cable through the basement, it's important to ensure that the cable is properly supported and protected. This can be achieved by using cable staples or running the cable through conduit or other approved raceways. Additionally, it's crucial to avoid damaging the cable during installation, as this could compromise its insulation and create a potential safety hazard. In summary, NEC 300.3 prohibits the mixing of different electrical systems within the same cable unless specifically approved for that purpose. Looping the travelers with two-wire NM cable for a four-way switch violates this requirement by combining the lighting circuit travelers with the power circuit conductors. The correct approach is to use 3-wire cable throughout the entire switch circuit, ensuring that the travelers and the power conductors are properly separated and insulated. Remember to follow proper wiring techniques and ensure that all connections are made correctly to maintain electrical safety and code compliance. By adhering to these guidelines, one can ensure a safe and functional 3-way and 4-way switch circuit. In addition to the above, it is important to understand the general requirements for wiring methods outlined in Chapter 3 of the National Electrical Code. This chapter covers a variety of wiring methods, including non-metallic sheath cable, which is commonly used in residential wiring. Non-metallic sheath cable, also known as NM cable, is a type of electrical cable that consists of 2 or more insulated conductors enclosed within a non-metallic sheath. NM cable is typically used for branch circuits and feeders in residential and light commercial buildings. When installing NM cable, it's important to follow the requirements outlined in Article 334 of the National Electrical Code. This article covers topics such as uses permitted, uses not permitted, installation requirements, and ampacity. Some key requirements for NM cable include: firstly, NM cable must be supported and secured at intervals not exceeding 4.5 feet. Secondly, NM cable must be protected from physical damage. Thirdly, NM cable must not be installed in wet or damp locations unless it is specifically listed for that purpose. Fourthly, NM cable must be installed in accordance with the manufacturer's instructions. In the context of the 3-way and 4-way switch conversion, it's important to ensure that the NM cable is properly installed and supported. This includes using cable staples to secure the cable to framing members and protecting the cable from physical damage. Additionally, it's crucial to avoid running the NM cable through wet or damp locations, such as basements or crawl spaces, unless it is specifically listed for that purpose. If the NM cable is exposed to moisture, it could compromise its insulation and create a potential safety hazard. Furthermore, it's important to consider the ampacity of the NM cable. The ampacity of a cable is the maximum amount of current that it can safely carry without overheating. The ampacity of NM cable is determined by the size of the conductors and the temperature rating of the insulation. When selecting NM cable for a 3-way and 4-way switch circuit, it's important to ensure that the cable has an ampacity that is sufficient to handle the load. This can be determined by calculating the total current that the circuit will be expected to carry and then selecting a cable with an ampacity that is equal to or greater than that amount. In addition to the requirements for NM cable, it's also important to consider the requirements for boxes and enclosures. Boxes and enclosures are used to protect electrical connections and provide a safe means of terminating conductors. Article 314 of the National Electrical Code covers the requirements for boxes and enclosures. Some key requirements for boxes and enclosures include: firstly, boxes and enclosures must be of sufficient size to accommodate the conductors and devices that they contain. Secondly, boxes and enclosures must be securely fastened to a supporting surface. Thirdly, boxes and enclosures must be protected from physical damage. Fourthly, boxes and enclosures must be installed in accordance with the manufacturer's instructions. In the context of the 3-way and 4-way switch conversion, it's important to ensure that the boxes are of sufficient size to accommodate the conductors and devices that they contain. This includes the 3-way switches, the 4-way switches, and the wire connectors. Additionally, it's crucial to securely fasten the boxes to a supporting surface to prevent them from becoming loose or damaged. Furthermore, the National Electrical Code provides specific requirements for the grounding of electrical systems. Grounding is the process of connecting electrical equipment to the earth, which provides a low impedance path for fault current to flow back to the source. Grounding is essential for electrical safety, as it helps to protect people from electric shock and reduce the risk of electrical fires. Article 250 of the National Electrical Code covers the requirements for grounding. Some key requirements for grounding include: firstly, all electrical equipment must be grounded. Secondly, the grounding conductor must be sized in accordance with the requirements of the National Electrical Code. Thirdly, the grounding conductor must be connected to a grounding electrode, such as a ground rod or a metal water pipe. Fourthly, the grounding system must be tested to ensure that it is functioning properly. In the context of the 3-way and 4-way switch conversion, it's important to ensure that the electrical system is properly grounded. This includes connecting the metal boxes to a grounding conductor and ensuring that the grounding conductor is connected to a grounding electrode. Additionally, it's crucial to test the grounding system to ensure that it is functioning properly. The National Electrical Code also provides requirements for overcurrent protection. Overcurrent protection is the process of protecting electrical circuits from excessive current, which can cause overheating and damage to equipment. Overcurrent protection is typically provided by circuit breakers or fuses. Article 240 of the National Electrical Code covers the requirements for overcurrent protection. Some key requirements for overcurrent protection include: firstly, all electrical circuits must be protected by overcurrent devices. Secondly, the overcurrent devices must be sized in accordance with the requirements of the National Electrical Code. Thirdly, the overcurrent devices must be readily accessible. Fourthly, the overcurrent devices must be labeled to indicate their ampacity. In the context of the 3-way and 4-way switch conversion, it's important to ensure that the circuit is protected by an overcurrent device such as a circuit breaker or a fuse. The overcurrent device should be sized in accordance with the requirements of the National Electrical Code, based on the ampacity of the conductors and the load that the circuit will be expected to carry. Additionally, the overcurrent device should be readily accessible and labeled to indicate its ampacity. Remember to always consult the latest edition of the National Electrical Code for the most up-to-date requirements. Furthermore, consider local amendments or regulations that may apply to electrical installations in specific jurisdictions. Working with electricity can be dangerous, so it's essential to follow proper safety precautions and seek professional assistance if needed. If you are not comfortable working with electricity, it's always best to hire a qualified electrician to perform the work. A qualified electrician has the knowledge and experience to ensure that the electrical installation is safe, code compliant, and properly functioning. They can also provide valuable advice and guidance on selecting the right materials and equipment for your specific needs. In addition to the technical aspects of electrical installations, it's also important to consider the aesthetic aspects. The appearance of electrical wiring and devices can have a significant impact on the overall look and feel of a space. When installing electrical wiring and devices, it's important to choose materials and finishes that complement the surrounding decor. For example, you can use wire concealers to hide exposed wiring or choose decorative switch plates and outlets to add a touch of style. Also, there are many resources available to learn more about electrical wiring and safety. These resources include books, articles, websites, and training courses. By taking the time to educate yourself about electrical safety, you can help protect yourself and others from electrical hazards. Remember that electrical codes and regulations are constantly evolving, so it's important to stay informed about the latest changes. You can do this by subscribing to industry publications, attending training courses, and consulting with qualified electrical professionals. By staying up to date on the latest codes and regulations, you can ensure that your electrical installations are safe, code compliant, and properly functioning. Safety is paramount when working with electrical systems. Always energize circuits before working on them and use appropriate personal protective equipment. If you are unsure about any aspect of an electrical installation, consult with a qualified electrician. By following these safety precautions, you can minimize the risk of electrical shock and other hazards. By using 3-wire cables, one can prevent the power and light systems in different cables from causing a hazard. If both systems were in the same cable, it would go against NEC 300.3 and it could lead to a dangerous scenario.